All right, here's your homework video on finding missing sides and angles using SOHCAHTOA and some stories to do with the same thing. So how would you solve for this missing side using that? Well, step number one is to recognize the angle given. And then recognize what do I know and what am I looking for. So 24 is the opposite side. X is the hypotenuse, and which trig ratio uses those two things? That's where we need to know. So recognize sine does. So sine of 47 is equal to opposite, which is 24, over what I'm looking for, which is x. Then I just need to solve for x. So to get x by itself, I'd multiply both sides by x, and then I would divide by sine 47. And that's what you'd put in your calculator. Now, make sure your calculator is in degrees, if it's in degrees, or radians, if it's in radians. So, for instance, this calculator that I have right now, if I look at the bottom, is in radians. It says RAD on the bottom. So how do I change that? So underneath alpha is a mode button. Press the mode button. And then what you'll see after you press the mode button is an option to change it from radians to degrees. So you go down to radian. See how it's blinking? Radian. Oh, there it is. Radian. Push to the right, and then go degree and press enter, and twice press enter, and now at the bottom says DEG, and now you could type in 24 divided by sine. Recognize where are the trig functions on this calculator, and they're in blue. So they're above y, z, and t. So blue. So I'm going to press second function y to get sine, and then I'm going to put in 24 and make sure 47, and then close the parentheses. For these questions, we're going to go diamond enter to approximate it. So the approximate answer is 32.8. All right, number two. I want to find the angle in this case that's missing. There it is. So what am I given? Opposite and adjacent. So it's tangent. So tangent of theta is equal to opposite over adjacent. And then to get theta by itself, you do the inverse of tangent. That's that little -1. And then we need to know where that button is on our calculator, that little -1. So if I look carefully above the T, in gold or yellow or green or whatever color that is, you'll see a little -1. So I'm going to press diamond T. And when I press diamond T, you can see what comes up. And then inside would be 3 over 14. Close it, diamond enter. So 3 over 14, diamond enter, and you can see the angle in degrees, which is about 12.1 degrees. Number three, again, I'm looking for an angle. What am I given? So 39 is the opposite, 45 is the hypotenuse. So to find a missing angle, it's going to be sine, and it's 39 over 45. When I say opposite, that's silliness. That is adjacent. So it's not going to be sine, it's going to be cosine. Adjacent over hypotenuse. So to get theta by itself, you do the inverse cosine, and then use your calculator. So again, inverse cosine is going to be that diamond button first, and it's where z is. So diamond z, and then you type in 39 over 45, close it, diamond enter. So what is that angle? About 29.9 is the angle. All right, number four. What am I looking for here? A missing side. Let's make sure I do this right. So the angle is right there. So that is the adjacent side, and 18 is the hypotenuse. That's again cosine. So cosine 41 is equal to the adjacent side over the hypotenuse. To get x by itself, you multiply by 18, and then just type it in, 18 cosine 41. So we're going to type in 18, cosine is the blue button, and then 41. So not inverse unless you're finding the angle, and it's 13.6 if you want to round it. Number five. Oops. I'm looking for a missing angle. So what do I got? That is opposite and hypotenuse. That's sine of theta is equal to 4 over 7. To get theta by itself, it's inverse sine of 4 over 7. And then use your calculator. So for this one, it's diamond y for inverse, and then type in 4 over 7, yeah. Diamond enter. So it's 34.8. Number 6, I'm looking for a missing side. So what am I given? So this is the opposite side, this is the angle, and x is the adjacent. So opposite and adjacent, so that's going to be tangent 65 is equal to 31 over x. To get x by itself, you'd multiply by x and then divide. So when you divide by tangent 65, that's x by itself. And then type that in your calculator and you get 14.5. Alright, when you're asked to solve a triangle, you're finding all the parts that are missing. So what's missing here? A, B, so A to B, A to C, and so on. I'm going to label some of these things. So I'm going to label that X, I'm going to label that Y, and then we have angle C right here. We can label that theta. Now the easiest one to solve for first would be theta here, or angle C, because we know two angles in the triangle. We know they have to add up to 180. But for a right triangle, even more so, the two acute angles have to add up to 90. So if you go 90, take away 50, that missing angle is 40. No trigonometry, just basic geometry. To find AB, that missing side, go with the angle you're given and think, okay, I know the opposite side and I'm looking for the adjacent. So that's tangent 50 is equal to 14 over x. To get x by itself, you multiply by x and then divide by tangent 50 and then use your calculator. So that's about 11.7. And then to find the hypotenuse, we're still going to use 50 degrees and 14, but this time the hypotenuse h, we're going to use sine because it's opposite and hypotenuse. So the sine of 50 is equal to opposite over hypotenuse. And again, to get y by itself, multiply and then divide by sine 50. And that answer is about 18.3. A good indicator to know maybe you did it wrong is if the hypotenuse is not the biggest number in terms of the sides of the triangle. So it's good that 18.3 is the biggest because that's the hypotenuse. All right, number 8. Solve for all the parts that are missing here. So what's missing? K to L. Well, I'm going to label that x. And since it's a right triangle, we know two of the sides. No trigonometry here. It's just the square root of 23 squared minus 16 squared. So if we do that, the approximate answer is 16.5. To find the missing angles, though, we do need trigonometry. So if I want to find angle L, and the angle and the L kind of look similar, don't they? Anyways, if I want to find this angle here, recognize opposite and hypotenuse. That's sine. And to find a missing angle, use the inverse sine of 16 over 23. Use your calculator, and you would get 44.1. So that's angle L, 44.1. And then, to find the missing angle, it's J. And for J, start again from the beginning, 16 and 23. So it's adjacent. So in this case, for J, we can erase this. And this is now the adjacent side in the hypotenuse. That's cosine. So to find a missing angle, we use inverse. And again, it's 16 over 23. But now we're using inverse cosine. These are going to be, and we don't even need to do that. These are going to be complementary. They're going to add up to 90. So I don't even need trigonometry here. I could have simply went 90 subtract 44.1 and saved myself some time. And that would be 45.9. All right, turn the page. Solve for this triangle. F to G is the hypotenuse. So if I want to solve it, it's the square root of 2 squared plus 4.6 squared. Use your calculator. You can always press pause if you want to use your calculator first. But that answer is about 5. For angle F, I look and I go opposite over adjacent. Well, that's tangent. So the inverse tangent of 2 over 4.6. So that would be about 23.5. I'm not going to make the same mistake twice. The measure of angle G then would just be 90 subtract 23.5, and that's 66.5. And then you can fill those in. All right, one more time. Can you solve a missing right triangle? Find all the parts that are missing. So I want to find the missing angle first. So to find that missing angle, I just have to go 90 subtract 64. So that would be 26. To find the missing side, though, I need to actually use trigonometry. So from the angle NP, I'll label that X. That's opposite and adjacent. Well, that's tangent. So the tangent of 64 is X over 15. To get X by itself, you multiply by 15. And then use your calculator. So 15 times tangent 64 is 30.8. Now for this one, you could use actually the Pythagorean theorem because you know two sides, but I'll use trigonometry again. To find the hypotenuse using this, that is adjacent and hypotenuse from 64. So that's cosine. So cosine 64, adjacent over hypotenuse. To get y by itself, you multiply and then divide. So this is what it would look like. 15 divided by cosine 64, and that's 34.2. All right, let's do some stories. A 50-foot ladder is leaning against a vertical wall. The base of the ladder is 45 feet from the base of the wall. Find the angle. That's what I'm looking for. The bottom of the ladder makes with the ground. So we're going to draw this situation quick. So we have a wall, and to that wall a ladder is leaning against it. You can obviously see the right triangle there. What do we know about this? The ladder itself is 50 feet. We know that if the base of the ladder is 45 feet from there, so here's the base of the ladder and the base of the wall, that's 45 feet. What we're looking for is the angle the bottom of the ladder is making with the ground. So this angle down here where the two meet. So if I want to find that angle, what do I know? So it's adjacent and hypotenuse. So that's cosine. So it's inverse cosine, 45 over 50. And that angle is 25.8 degrees. All right. Joel is ziplining. If the vertical distance from his platform to the next platform is 304 yards, and the angle of depression is this, and it's given in minutes and seconds, find the length of the zip line. So what do we know so far? The vertical distance from his platform to the next platform is 304 yards. And the angle of depression, so we have this distance, he's zip lining down here, but the vertical distance down, so here he is zip lining, going down. Here's the other platform. If you go directly down, the vertical distance down, it's 304 yards. And then the angle that we're looking for is right here, and that angle up there, the angle of depression, so actually the angle of depression would be like this. It would be like 21 degrees, and then that would actually be here. So the angle of depression is made with the horizontal. If I do that Z pattern, it would be also the same as down here with parallel lines. And then what we're looking for is the length of the zip line, that hypotenuse right there. So, see how we have minutes and seconds instead of decimal? If I wanted to convert it, so I have 21 degrees and then 43 minutes and 30 seconds. That is, think of it as part of a clock. Like 60 minutes would be, 60 minutes is equal to 1 degree. So if 60 minutes is equal to 1 degree, and we have 43 minutes and 30 seconds. That's 43 and a half, a fraction, right? And what is that fraction that's going to help me out of 1 degree? So 43.5 divided by 60. So you'd have it 0.725. That's the decimal fraction of 1 degree, right? That's another way to describe the size of an angle. So 43 minutes and 30 seconds out of 60 minutes, which is 1 degree. What fraction is that? So it's 21.725. That's what this is down here. So if I want to find the hypotenuse then, what do we got? So we got opposite and hypotenuse. That's sine. So the sine of 21.725 is equal to 304 over x. So to get x by itself, you'd multiply and then you would divide by sine 21.725. So what's that answer? Is 821.3 yards. All right, 13. A string is connected to connecting the corner of a square canopy to a point on the ground 15 feet from the base of the canopy. If the angle of elevation from the point on the ground to the corner of the canopy is 37 degrees, find the length of the string. So we have a string that's connected to some kind of square canopy here, and this, which is in the air, right? This kind of canopy thing here that's a square. You can't even draw a square. Anyways, it's connected to the ground. So there's the string connected to the ground. And that string, I don't know the length of. But there's your right triangle. What do we know? That a string is connected to the corner of a square to a point on the ground 15 feet from the base of it. So right here would be this string connected to the base is 15 feet. So you have a string connected to the ground, the base of the canopy, that length there is 15 feet. The angle of elevation, that's the angle looking up to the canopy, is 37 degrees. That's down here. And then we're solving for the length of the string. So look at the angle. That is adjacent over hypotenuse. That's cosine 37 is equal to 15 over x. To get x by itself, you multiply and then divide by cosine 37. And then use your calculator, and you get 18.8 feet. Done. Length of the string. All right, last one. A hot air balloon is at a festival. Erica spots a red balloon due east at an angle of 36 degrees. She turns due west and sees a blue balloon at an angle of 51 degrees. If altitude of the red balloon is 296, the altitude of the blue balloon is 461, and Erica is 1.6 meters tall, find the distance between the balloons. So let's break this down. So we have Erica here, and she looks due west and sees a balloon. So west is this way, and she sees a balloon in the air. There's my hot air balloon. And what do we know about it? Well, we know the balloon is the one due west. You know the angle up to that she's looking at is 51 degrees. And the blue balloon is 461 meters. So which one's west? She turns due west and sees a blue balloon, right? And the blue balloon is 461. But she's 1.6 meters tall. So really, we can subtract them and get 459.4 as the height from her eyes. Then she looks east, and it's not quite as tall. Again, there's a balloon here to the east. This is the blue balloon. This is the, what's the other color? Red balloon. For the red balloon, it's 296, but again, I need to subtract 1.6. So it's the height from her eyes, not from the ground. So think of this as 1.6 down. Here's the ground. So from her eyes, what is that height? And that's 294.4. And again, the angle of elevation up to there is 36 degrees. So there's our setup. And the question is, find the distance between the balloons. So that's this distance here all the way across. So we have an X and a Y. If we add that up, these two sides of the right triangle, that's the complete distance across. So we need to just set this up twice. So for both of these, it's going to be tangent because we don't know the hypotenuse. So the tangent of 51 is 459.4 over x, and again we're going to multiply and divide, so it's 459.4 divided by tangent 51. That's 372 about. Then we're going to do the same thing with tangent 36, 294.4 over y. To get y by itself, multiply and then divide. And that answer, 294.4 divided by tangent 36, is about 405.2. And then we're just going to add these together. So if you add them together, you get about 777.2. And that's meters. So what's the distance between them? We're adding those two together. And the distance between them is about 777.2. All right, great job doing your homework. Good job, good job, good job. Mr. G Math, over and out.